We are carrying on with our notes on qualitative analysis. We've done the first page, we've done one example, and now we're going to do the next two examples in this video. So again, we have negative ions. They happen to be hydroxide and sulfide. So we're looking for something that takes out the OH minus but leaves behind the sulfide, or something that takes out the S2 minus but leaves behind the OH minus, is soluble. So it means there are many right answers. So we're looking sulfide and hydroxide. So here's our sulfide, here's our hydroxide, and we're looking for things that will do the trick. We can see strontium won't do it because it won't precipitate with either of them. But calcium will work because here it's soluble and here it would fit the category of all others and be low solubility. And the same is true for barium and magnesium and beryllium. So let's see what we chose behind the door. Fried chicken, get moving there. There we go. So if we add barium, and we add in the form of barium nitrate, that's how we deliver it. It's going to go after the OH minus and leave the S2 minus behind. So then we write our net ionic equation, and that's what we'll filter out. The S2 minus passes through the filter paper in a filtrate, and now we're off to the races. Because the hydroxide's gone, we can add any ion we want that's low solubility. So we're looking for a positive ion that isn't one of these. So many right answers. That's why these are a pain to mark. So we say, hey, let's throw in aluminum 3+, in the form of aluminum nitrate. Net ion equation, here's our 3 and our 2-. So we get Al2S3, all nice and balanced, and we filter, and it is done. That's it. May look easy in the notes, but usually when you're seeing these questions for the first time, not so easy. Now we're going to be meaner. Now we're looking at 3 ions. Silver, iron 3+, and Sr2+. And you will notice they are positive ions, so that means we have to add negative ions. We have to add anions. See how it says anions there? Anions, they're going to take out one and leave behind the others. So this one's tough because we have to take out only one, leaving the others behind. Then once we've done that, we have to look for something that will take out the next one of the two. And then once we get the first 2 ions out, then we can add anything that's going to be low solubility. Well, what we talked about somewhere in our notes is that silver loves to precipitate out. It fits here, fits here, fits here, it fits there, it fits there. So if we add one of the halides, that is going to do the trick. And so you can see here, I'm going to add iodide. So when I add sodium iodide, NaI, that is totally soluble and it delivers the iodide ions. The silver attacks those and they get together and they make AgI. But iron 3+ and strontium 2+ are soluble with iodide. They pass through the filter paper and now we will attack them. So in this case, it says let's go after them with sulfate. And what happens if we add sulfate? Well, here's our sulfate. Strontium will attack the sulfate. And strontium, or the sulfate, will not go with the iron. It will be soluble. So when we do that, there's our net ion equation. We got our sulfate ions in there with sodium sulfate. The Fe3+ is left behind and will pass through as a filtrate. And then we are off to the races. We can go with anything that's going to take out the Fe3+. We could add sulfide, we could add hydroxide, or we could add any of those 3 complex ions. Let's see what's been chosen here. So we said, hey, let's go for sulfide, and that's in the form of sodium sulfide. There's our balanced equation, and then we filter, and we are home free. Again, I think if I make some diagrams for one of these examples, it will make it a bit clearer what we're physically trying to do. But if you get it at this point, that means you really are processing well.